Buoyant force is defined as the fluid force pushing up from the bottom minus the fluid force pushing down from the top. So we have this 4 by 6 by 8 box. It is beneath the surface of the water, some unknown depth, h. We want to come up with the buoyant force of that box. So the fluid force pushing up from the bottom would be how deep the bottom is. So that's 4 plus h. This is how deep the bottom of the box is, times the surface area of the box, or the bottom of the box, times the weight density of the fluid, which is in this case water, 62.4 pounds per cubic foot. So we distribute all that out and we have this expression for the fluid force pushing up from the bottom. Then we take the fluid force pushing down from the top. Again, it's the weight density of the fluid, how deep this portion of the box is, which is h feet below the surface, and then the surface area of that part of the box. Multiply that out, that gives us the 2995.2 h. And we subtract these two quantities, so the 11,980 2995h minus the 2995h, and we just wind up with the 11,980.8 pounds. That is the buoyant force of the box. Now, another way to look at that is really this 11,980.8 pounds is the same thing as if we took this box, 4 by 6 by 8 box, and we fill it up with water. If we fill that up with water, then it's the volume of the box, 4 by 6 by 8 cubic feet, times 62.4 pounds per cubic foot, gives us the same number. So the buoyant force, we can simplify our equation by using this equation. Force equals weight density of the fluid, the height of the box, and the area of the bottom, or the weight density of the fluid times the volume of the container. Now we can use this to answer another question. If the box weighs 10,000 pounds, then how far will the box stick out of the water? So if this box was just empty, but then we loaded 10,000 pounds of rocks into the box, then it's going to sink into the water some, but some of it will be sticking out of the water. So how far will it stick out of the water? Well, if we use this equation, the force pushing down on the box will be the weight of the box. That's 10,000. Weight density, 62.4. The depth of the water, that is here, how far of the box, how much of the box is underneath the water, that's part of what we're looking for. And then the area of the bottom. So we can solve that for h, and we wind up with 3.34 feet. That's how much of the box is underneath the water. And then we subtract that from 4 because that's the height of the box. And that gives us 0.66 feet sticking out of the water. Now, one other question we can answer. If we want the box to stick out of the water 1 foot, then how much should it weigh? How many rocks should we put in the box? So we can use our same F equals WHA formula. And we want, if it's supposed to stick out of the water 1 foot, then it's going to be underneath the water, the surface of the water, 3 feet. So 62.4 weight density, depth of the water, and then the surface area, or the area of the bottom, multiply it all out. So if this box weighs 8,985 pounds, 85 pounds, then it will stick out of the water 1 foot.